Hello and welcome to the webinar. My name is Josh McDaniel. I work with the Wildland Fire Lessons Learned Center. In a few moments we'll start the webinar and I'll introduce the script. But first I want to make a few quick notes. First I want to point out that the webinar series is a regular webinar for close to 2 years now. Is sponsored by 3 organizations: the Joint Fire Science Program, the International Association of Wildland Fire, and the Wildland Fire Lessons Learned Center. And I also want to, the IAWF, the International Association of Wildland Fire, wanted me to point out that they're having an international symposium on smoke and smoke management in Washington, D.C. in fall of this year. So you can check out their website for more information on that upcoming event. We have some webinars scheduled coming up in the month of March, and I wanted to point those out to you. First, Sarah McCaffrey, will be presenting on debunking myths in wildland fire on March 5th. Sarah has presented on this topic at a few of the recent conferences, and it's a very provocative, presentation about some of the conventional wisdom that in fire that Sarah's got some research that's starting to show a different story. And then on March 20th, Sam presents some new research she's been working on the economic impact of large wildfires in terms of what is the impact of fires on local communities where the fires occur. And you can register for those webinars at the Advances in Fire Practice page, and you can get there by navigating to it through the Lessons Learned Center's menu, or I've put up this is a new thing for me, these bit.ly addresses where I've sort of condensed it. I don't know if that's easier than the old one, which was longer, but there's a way you can get to it there. Or you can Google Advances in Fire Practice. Any of those ways will get you there. Yeah, excuse me. I'll introduce the speaker in a second, but I just want to let you first let you know how questions work. If you have a question, type it into the box in your control panel, which should be named questions or chat. We will collect all those questions, and after the presentation, we'll go through them during the Q&A session. Also, the webinar is being recorded and archived, and we will be posting that hopefully on the Lessons Learned Center's YouTube channel after the webinar, and you can find that in the same place you can register for the webinars on Advances in Fire Practice, and pass along that link to anyone who wasn't able to make it to the webinar that you think might be interested. Okay, so on to today. I'm going to go ahead and introduce the speaker. This webinar is presented by Stephen Link. Stephen received his PhD from Arizona State in 1983 and did his postdoc at Utah State working on bunchgrasses. He's been living and working in the Columbia Basin since 1985, operating his own company, Native Plants Landscaping and Restoration, which completed the research he'll be presenting today. He also works for the Confederated Tribes of the Umatilla Indian Reservation as a restoration ecologist at the Hanford site for the U.S. Department of Energy. And with that, I'll hand it over to Stephen.
Hi, I'm pleased to do this. First webinar for me. I'm going to talk about the management of cheatgrass fuel loading in the Shrub-Steppe.
Your presentation's not up yet. If you were trying to load your presentation, it's not up there yet.
I see it in front of me.
Oh, you do? Okay.
Yeah.
It's not up on mine.
Are you seeing? Should I end the show and start it over?
Let me, I'm going to take the screen back and I'll hand it back to you. Okay, here it's coming again. Yes.
Should I hit show my screen?
Yep.
Okay. How's that?
There you go. There we go.
Okay, I'll start over again. This is a talk on the management of cheatgrass fuel loading in the Shrub-Steppe. Cheatgrass, of course, is a big problem throughout the western United States. This work was started in 2002, and it's been funded by the Joint Fire Science Program. The work was done in cooperation with the U.S. Fish and Wildlife Service Mid-Columbia River National Wildlife Refuge Complex. And I give special thanks to Randy Hill for helping find questions and for continued technical support. I'm going to talk about 4 main topics today. One is cheatgrass, Bromus cover mapping and fire risk. Second topic is the effect of herbicide and herbicide concentration on Elymus wawawaiensis, or Snake River wheatgrass establishment. Then I'm going to talk about that was the first part of the experiment. Then I received further funding for monitoring, and that's to look at the responses 6, 7, and 8 years after the treatments. Did it really work? Lastly, I want to talk a little bit about fire risk in replanted bunchgrass communities. This work occurred in the central part of eastern Washington, and the pointers at the Columbia National Wildlife Refuge, where I did most of the planting work. The work at the fire risk study was done, whoops, I hit the wrong button there, but it was done at the Hanford site. So the first topic is cheatgrass cover mapping of fire risk. If we want to know how much trouble cheatgrass is, you have to know how much you have, and thus, what is the risk of fire? Can you have a little bit of cheatgrass? Does it have an effect? When does it become a serious effect? So I determined fire risk, and was able to map it over the landscape. So here's a picture of cheatgrass infestation at the Saddle Mountain element of the Hanford Natural Monument. And you can see right in front is cheatgrass. It's just generally nearly completely covering this area. See all the flags there. This is how I conducted my experiment for determining cover and fire risk. You can see high cheatgrass fuel load. This is very dense. You throw a match in that, it's just going to go. Okay. Here's a low cheatgrass fuel load. This area is dominated by Sandberg's bluegrass, Poa secunda, and cheatgrass. But this particular location has very little cheatgrass, and you can note the soil is open here, and thus fire risk is lower, most likely. And it is. I did a number of fire trials, and here I ignited a point on the ground randomly located, and it caught a little bit, but it died. So the likelihood of it carrying is less. There's just less fuel on the ground. That's the goal. This experimental design was done to define fire risk. So I set up replicates, 8 to 18 plots in the 3 lowest cover classes. Each replicate has a large number of plots such that I can count how many burn or not burn and compute a risk number. So then I went to each plot and ignited a fire, and if it burned and continued on a 10 meter by 10 meter plot, it was considered a fire. Otherwise, if it stopped, it was not. I also looked at the relationship between cheatgrass cover and remote sensing done by aerial photography with 3 color bands. So we can know what the risk is. With knowing where it is and how much there is, we can then produce a map of fire risk. Thus, I initiated fires, and I was able to determine how many fires occurred and compute risk, and then relate it to cheatgrass cover. Thus, we can see at roughly 48% cheatgrass cover and above, the risk of fire is essentially 100%. And if you can reduce it below that, fire risk is reduced. A few of my study plots had like maybe a few percent cheatgrass cover at the lower end here. So fire risk in a Sandberg's bluegrass community is minimally 30%. It's never 0. I was also able to then relate cover on the ground with aerial photography and relate cheatgrass cover to band intensity. Now, I did this in the middle of the summer when all cheatgrass was blonde. I did not do what is commonly done, is to take 2 pictures, one green and one blonde, to define exactly where cheatgrass is. I was able to relate it pretty well to cheatgrass itself. It has a distinct color. So this is reasonable. Thus, I was able to write a simple equation to define cheatgrass cover mapping, and you'll note that in the top slide. The green area is low cover. The orange or to red colors are high cover. You note roads, which are green, have little cheatgrass cover, and I was able to detect that using aerial photography. So thus, you can map cheatgrass cover with one shot in the middle of the summer. Thus, and just applying the equation for fire risk, I can then broadcast a map of fire risk, as you'll see in the bottom slide. And again, you can more clearly see roads as low fire risk. The areas to the left are more Sandbridge bluegrass. Areas to the far right are mainly pure cheatgrass. And the large area here, this is a gravel pit, so you can certainly map it now. In conclusions for a particular study is it is possible to map cheatgrass cover, taking photos in the late summer with a 3-color band aerial photography. This naked imagery now could be used, 1-foot resolution. Based on the cover map, the relationship between cheatgrass cover and fire risk can now be mapped. Of course, this is relevant to the Hanford site and maybe south central Washington. It may be different in other locations, in other contexts. Second story. Okay, so now we know we do have cheatgrass and it is a problem. We know where it is and how do we get rid of it? This is a perennial problem. This is not a brand new question particularly, but there were some new strategies for using herbicides, new herbicides. So we looked at the effect of herbicide and herbicide concentrations on Elymus, wawawaiensis, Snake River wheatgrass establishment in the Shrub-Steppe. The field site is at the Columbia National Wildlife Refuge, and the area in front is cheatgrass and Sandbridge bluegrass. The cheatgrass cover here is roughly 50%, 40 to 50%, and it is generally a continuous fuel load. I did this this experiment in the context of a prescribed burn. Well, before I did this burn, I set up 45 study plots, 3 herbicide treatments, 3 replicates of each, and 5 levels, so a total of 45 study plots. These are all assessed before the fire for cover and for species composition. Then in the fall, we did a prescribed fire in October. Right after that, we applied imazapic or Plateau herbicide at concentrations of 0, 1, 2, 4, and 8 ounces an acre. Those concentration levels are the same for Roundup, which was also used but applied in the spring, March 4th approximately. These herbicide levels were applied to the appropriate study plots, randomly chosen. Drill seeding was done in February 19th, 2003. Seed was applied at a rate of 7 pounds per acre. Plateau has a long herbicide activity in the soil, so this is about 3 months after herbicide application. Okay, in the following spring, later in the spring, we can see some results of various herbicides and their effect. Roundup at 2 ounces an acre had an effect on the tumble mustard, which is what you see in the interrow spaces and elsewhere in the study area. To the right is the treatment. You can see little tumble mustard, some Amsynchia, and cheatgrasses there. So it didn't really have a strong effect. Plateau at 2 ounces an acre has a different effect. It certainly had a strong effect on tumble mustard. Actually, at 1 ounce an acre, tumble mustard was pretty much just taken out by Plateau herbicide. But at 2 ounces an acre, it really it's not having a strong effect on the Bromus tectorum as of yet, which is primarily what is visible to the right. Sandbridge bluegrass is throughout the area too. Then at Plateau of 4 ounces an acre, you can see the study plot design here. A split plot, half the plot was drill seeded, the other half was without drill seeding, but treated too. And you can see the color of is different. It's darker, more soil or litter is visible now, and less vegetation. Here is Plateau at 8 ounces an acre. Again, you can see to the left is a control area, quite strong with temple mustard. You see it removed a fair amount of cheatgrass, not all of it, but it's patchy. You can now see the sandbridge bluegrass in the foreground, and various flowering plants such as phlox salted through the area. So we drill seeded, of course, and in each of these plots I counted the number of seedlings that emerged in each drill row in the entire study plot. Then I related that to the size of the study plot and related that then to concentration of the 3 herbicides and herbicide treatments. The take-home message here is that it appears that imazapic or Plateau elicited a better response at 4 ounces an acre, which is 0.3 on this scale. So 4 ounces an acre or 18 ounces an acre are essentially equivalent. Thus, I suggest 4 ounces an acre is appropriate for under these study conditions. Roundup kind of worked at the highest level. It was highly variable, and the 2 applications, of course, didn't do much good at all. Okay, so thus that was the end of this particular study. Now, we redid it or reassessed it beyond that. We looked at management of fuel loading 6 and 7 and 8 years after the treatment. How long does this effect work? Okay, for this objective was to determine if our strategy to reduce cheatgrass cover and thus fire risk is sustainable after implementation. Again, we seeded in February of 2003. We tested 3 hypotheses. The first hypothesis is bunchgrasses established in 2003 will show an increasing degree of cheatgrass control over 3 years. One would be happy if it continued to be strongly decreasing control of cheatgrass cover. Second hypothesis, since herbicides can have an effect on the native flora, is worth considering the consequences of using Plateau. Plateau itself is a very serious herbicide, and as time has gone on, there have been some errors using this herbicide, and it can cause problems. But so at least we were able to look at native species richness. I counted, I did a species composition on each study plot at every year I did the study. So I know how many native species were there, and they're covered. So we looked at this in the Plateau plots. I combined 4 ounces an acre and 8 ounces an acre for this treatment assessment to have 6 replicates. The effects were similar, so I lumped them. Okay, so these cover and richness, the hypothesis is that it will not be different from controls 6, 7, and 8 years after treatment. Third hypothesis, will alien species cover in Plateau plots by itself will not be different from controls 6, 7, and 8 years after treatment. If Plateau itself had a strong and lasting significant effect, we would see alien species cover reduced compared to controls for hopefully a long period of time. To do these assessments, I monitored populations of flowering and size of established bunchgrasses. I also documented new seedlings arising from self-seeding. I also looked at well, the status or senescence in this particular species. Furthermore, I also looked at the size of the plant and the effect of its interference with the establishment of cheatgrass near the bunch itself. Okay, now here we see an example of what can occur when CCAR is planted into this location. Before I started this entire experiment, I wasn't aware of this, but just adjacent to my study plot areas, an area had burned in 1986, and it was drill seeded with CCAR. and you can see the results of this 18 years after establishment. The bunchgrasses appear to be in a healthy condition. There's very little cheatgrass in vision here, and there's lots of Sandbridge bluegrass. You can note an apparent preponderance of Sandbridge bluegrass in apparent drill road strips. So this is a good outcome, and at least I was able to look at other particular treatment combinations to see how well we can achieve this particular condition. I also determined the amount of fire risk in this particular restored condition, which I'll show you a little bit later. This is the last year of my study. This is after 8 years, and the plot to the right is the drill-seeded, I think it might be an 8 ounces per acre plot of Plateau. And you can see the system is opening up a bit, and the bunchgrasses appear to be healthy and sizable. Before I go back to this once a little bit, when the time I did this study, I was under the impression that seacar was blue bunch wheatgrass. And I'm slightly embarrassed, but it's not. It's a different genus, of course, and this is a recent activity for the taxonomic refinement of our knowledge of our bunchgrasses. Pseudoregnarius spicata, or blue bunch wheatgrass, is found at this particular location. It's not very common, though. And seacar has been used prevalently throughout the West, developed by the NRCS, and is commonly used. I will demonstrate some other aspects of this particular species a little bit later. Results on cheatgrass cover and how the treatments appear up to 8 years after application are demonstrated here. In 2008, 9, and 10, the effect remains the same. Herbicide plus planting results in a significant reduction in cheatgrass cover, down to roughly 17 to 8 to 20% based on the year. Control levels, you can note that in 2008, the cheatgrass cover in the controls were almost 40%. In 2009, it had risen to like 46%. And in 2010, it's a little over 50%. So cheatgrass is continuing to increase cover in this particular location, or it is subjected to yearly variation for varying reasons. This cover of cheatgrass demonstrably increased in the other study plots too. The planting treatment was simply planting a seacar without herbicide application, and this is not significantly different than controls. The other treatment was simply the use of herbicide, and this is Plateau again. And what effect does that have on cheatgrass cover? And again, it's not statistically different than controls in any condition. So Plateau itself will not result in a significant effect on cheatgrass control. Adding the competitive bunchgrass, though, is the strong factor here, and it significantly reduced cheatgrass cover again. So this is a good result. Okay, now again, one question is, what effect does the herbicide itself have on the native flora? I compared species composition in control and treated areas for all time periods here. And the first 2 years, herbicide had been treated and applied for the 2003 event, but there was no effect on species composition. The second year, though, 2004, I detected a significant increase in species composite richness in native species in the imazapic plots. By 2008 and beyond, that effect dissipated, and the richness of all the study plots was really no different than controls. So my interpretation of this is that the imazapic itself created a disturbance or a change in condition, opened up niches such that other species could establish or arise from the seed bank. But once the system closed up again, these niches disappeared and those species went back to bed or didn't make it. So the carrying capacity of this particular system is likely to be 10 to 12 species per plot in this particular study. So no lasting effect of imazapic application on species richness. Now, species cover, native species cover in years after fire and treated plots only, controls, we see the native species have not really changed in their cover condition, so no effect of fire on that condition. Alien species, though, and this is by and large cheatgrass, cover is increasing and significant years after the fire. So this is an effect of fire, and it is significant and not unusual, showing strong effects on dynamics of cheatgrass populations. I further looked at the effect of Snake River wheatgrass cover on cheatgrass cover. Now, I had lots of replicates, and so I simply looked at the relationship between cover and of both of these species. And when in 2008, 9, and 10, you can see that as cover in a particular plot is greater, the effect is strong on cheatgrass cover. All the points to the left where Snake River wheatgrass cover is 0 were controls essentially, and they again show the variability and increasing amount of cover as time goes on. And again, as Snake River wheatgrass cover increases, the amount of cheatgrass cover decreases. Another way to look at the effect of Snake River wheatgrass is to look at the effect of size of the plant on interference distance on this system here. Interference distance is the distance away from the center of the bunchgrass that apparently the bunchgrass influences and restricts cheatgrass cover or establishment. I set that level to be 10%. If cheatgrass cover was less than 10%, I considered it to be interfered with by the bunchgrass. Interspace areas in this particular study had cheatgrass cover well above 50%. And as might be expected, the larger the bunchgrass, the stronger its effect on its surroundings. And I would say that a largest bunchgrass I observed had an effect of a distance of 1 meter interference distance on surrounding cheatgrass. So this can help understand planting density requirements into the future. What happened to the Snake River wheatgrass itself? These were all drill seeded, of course, and I wanted to note dynamics in the populations. We can see apparent increases. This is the number of plants per plot. I counted every plant in every plot. They're easy to observe. They arose in drill rows with little confusion. But there's not a statistically significant change in populations here. I think they're going up. I could certainly count more in total. And you can see this in the total number of Snake River wheatgrass plants after planting. There's a couple of caveats here. The drill, I noted 0 seedlings outside of drill rows. I found small plants in drill rows, but just a handful. So I'm not certain if this plant is reestablishing itself. I think it is, but it wasn't clear to me. It's possible that I missed some plants in the 2 year after planting planting observation period. But if they're not establishing and reseeding themselves outside the drill rows, well, that might be sufficient, but it won't last forever. That's a negative issue for this particular species. Another way to examine this species was to look at the percent flowering. Are they producing more seed as time goes on? And this is surely the case. More of the plants that got bigger, and they put on more flowering after up to 8 years. So they appear to be healthy. Unfortunately, as I was watching these plants, I noted some of them appearing to senesce, and they were certainly gray in the center, as you can see in this slide. The rim around the edge of this bunchgrass has some green stems, and that's a normal condition when plants are senescing. At least bunchgrasses, the center will hollow out. But this was disconcerting. Of course, I classified plants as senescent if they had a significant amount of gray tissue in their crowns. And after tracking all these, I did note a significantly increasing percent of senescent plants in my study plots. This is not a good observation. Here's a worsening story. The population seeded in 1986 near my study area certainly show a rather large and spatially dispersed pattern of senescence. You can see brown areas to the side. Those are apparently healthy patches. These die-off areas are patchy in this particular location. I don't have a good reason for this, but it can't be age because my plants were senescing too, and they were only 8 years old, and these were 23 years old. Some other factors involved here. This simply leads to considerations for using CCAR as a viable long-term strategy for restoring bunchgrass areas disturbed with cheatgrass in the Shrub-Steppe, at least in our location. I have noted long-term stability. I've planted CCAR in other areas at the Hanford site and even drier locations. By the way, the rainfall levels here are 8.5 inches at the Columbia National Wildlife Refuge. I've seen CCAR do very well 18 years after planting at the Hanford site, and it has 6.5 inches of rain planted in a similar soil. So I'm not certain it's an age effect. I'm not certain why these plants are dying out, but it's worthy of consideration or further investigation. This leads me to suggest, of course, that use of locally derived native plants is likely a good idea. CCAR was derived from plants near Clarkston from a small population and grown out for planting throughout the West. This might be a local circumstance here, but it is apparently the case. Okay, so if we look at the density of Snake River wheatgrass, how well did I do in this particular project as an effector of cheatgrass cover? You can see, again, the cheatgrass cover without any Snake River wheatgrass was variable, from 36 to average of 47% cover in the 3 years of my particular study in this particular topic area. You can see my plants at a density of 1.3 plants per square meter. Elicited a reduction in cheatgrass, which retains its condition. I would not say, I think my hypothesis that the Snake River wheatgrass would continuously decrease the amount of cover in cheatgrass is not the case. I see cheatgrass cover increasing, but it's also increasing in control areas. So the Snake River wheatgrass probably has a potential, it has an effect, but other factors allow cheatgrass to continue to increase. And I believe this is mainly because the density was not strong enough to really reduce cheatgrass cover, which is what it was 18 years after planting, and noting the square at the far right, where cheatgrass cover was only 2.77%. I didn't repeat those samples, but the area appears to be in a similar condition when I looked at it a few years ago. If I were to do this experiment over again, this density was elicited after using 7 pounds per square acre of Snake River wheatgrass drill seeded. If I had doubled the seeding rate, I suspect I would have had a higher density of Snake River wheatgrass. So in the context of a prescribed fire and the Plateau herbicide, one could suggest using 14 pounds per acre of this particular species. Again, remember that imazapic is a pre-emergent, and it has a long life history in the soil. It can affect germination, of course. The use of Plateau has come under some scrutiny as it's become used more widely. Some circumstances where apparently it's been used without reading the label very well has resulted in significant die-off. This herbicide should not be used in the spring. It is to be applied in the fall as a pre-emergent. Overuse of the herbicide has disastrous effects, and planting right after application of the herbicide is not going to result in it. It's not going to be a good idea. The seed growers and people planting restoring bunchgrass areas in central Washington are no longer real happy about imazapic. Okay. Last topic here is fire risk in replanted bunchgrass communities. So if we get rid of cheatgrass and put a lot of bunchgrasses in, are we really reducing fire risk? And I was able to look at 3 topic areas at the Columbia National Wildlife Refuge to assess this. Again, I set up replicate plots and burned them, and determined how many plots out of 10 burned to compute risk. As we see here, fire risk range from 66 to 78% in the 3 bunchgrass replanted areas. None of these are significantly different, so it really isn't a big effect. It is less than 100% though, which it is when cheatgrass dominates the system. So you can reduce risk of fire potentially 25 to 30% in a high density planting of bunchgrasses. The soil cryptogam, the open soil condition, is really not significantly different either, although I might suggest it's slightly higher at the Hampton Lake site. But all the same, the amount of bunchgrasses that are planted will reduce cheatgrass cover, but it won't reduce fire risk to low levels of these large bunchgrasses. This is the density at which these bunchgrasses were found in these areas here. The Hampton Lake area was 2.77 plants per square meter. Lake Marie, the total there is close to 4, and is also close to 4 at Scalp Lake. Perhaps a lower density is a good idea, or using a different species such as Sanders bluegrass, which is a much smaller canopy and will produce less cover. That has not been examined. Okay. Now, when I was able to combine all this information on fire risk and compared it related it to the amount of soil and soil cryptogams, or bare surface area on the ground. And I found a very nice relationship between fire risk and cover of soil cryptogams, as you might imagine. And it didn't matter if it was planted with small bunchgrasses or large bunchgrasses, at least in the topic area I looked at. The small bunchgrasses are at the sides, and the lowest fire risk was a little lower than maybe 45% at the highest amount of open soil in these particular ecosystems with sandbridge bluegrass. So I would like to suggest that sandbridge bluegrass might allow this condition to prevail. So management implications here. Cheatgrass cover can be significantly and sustainably reduced by burning and applying Plateau herbicide at 4 or 8 ounces an acre in the fall, and then drill seeding CCAR in the late winter. Sustainable is a, maybe I shouldn't say sustainable now that a number of them are senescing, at least sustainable for maybe up to 10 years, which is not really sustainable. But that's an open question. I don't know what the condition of these apparently senescent plants are, but I will examine them in the spring when I go up on the field day, which will be somewhere between April 15th and April 19th when this will be open for people to attend. This will also be advertised. Okay, 7 years after the treatment application, the density of drill-seeded Snake River wheatgrass was 1.23 plants per square meter. Again, if I double seeding rate, it may increase the density enough to further reduce cheatgrass cover to be closer to the minimal value of 2.8%. And that was achieved with a high level of Snake River wheatgrass. Now, research questions. After all this work, I was impressed with the effect of the senescence on the bunchgrass that I planted. So I think a good question is to examine the viability of bunchgrass cultivars that arise from small initial plantings or narrow genetic conditions leading to population bottlenecks that may reduce viability. Are locally sourced native plants more likely to sustain themselves? I think that's a good question, and I suspect people are looking at that one. Second research question here is to examine the fire risk of more restored plant communities. What combination of species leads to significant reductions of fuel cover and increases in bare soil and soil cryptogams? Can sandbridge bluegrass itself provide sufficient interference to reduce cheatgrass cover? If this can be done, then the options for planting are increased, and the fuel loading associated with sandbridge bluegrass will be lower because it's a much smaller bunch grass. Lastly, I'm going to show you, I just gave this talk to a group of farmers who are in the business of trying to replant Conservation Reserve Program lands just a week ago. I prepared a list of bunch grasses that they could use and that are available from seed growers, and the current species are being offered are all native species, and I don't see any cultivars in this list. That's the end of my talk. I think this topic area has a lot of relevance to conditions, and in the western United States, I would say one should be prepared to spend $600 an acre to create the restoration activity. You multiply that by all acres in the western United States, and we'll have to raise taxes. That's it. Thank you very much.
All right. Well, Stephen, thank you. There's quite a bit of information presented there in a short amount of time. That's nice and concise. There are some questions starting to roll in. If you have a question, go ahead and type it into the questions box down in the bottom of your control panel, and we'll try to work our way through them. It looks like Ryan Shane has quite a few questions here. We'll start working through some of Ryan's questions. And the first question is, does percent fire risk mean the percentage of ignitions that result in a fire?
Correct. Plus the continuation of the fire in a 100 square meter study plot. If it ignited and continued beyond to the edge of the study plot, then it was considered a true fire. If it stopped within the plot, it was not considered to be a true fire.
Okay, gotcha. Okay. This is from Ryan as well. What is the what is the annual amount and timing of precipitation on the study site?
This particular area is the Mediterranean climate. Rainfall occurs primarily in the fall, last half of October into the spring. It's very dry in the summer, so it's a Mediterranean climate. Wet in the winter, dry in the summer.
Okay. This is from Keenan Bender, and Keenan wants to know, what's the definition of interference distance?
Interference distance is the distance away from the center of a bunchgrass where cheatgrass cover was below 10%. That simply indicates that the extent of the influence of the bunchgrass, as the bunchgrass is bigger, its influence increases, and the distance away from the center of the plant where cheatgrass no longer is dominant is the interference distance.
Okay, gotcha. Okay. Another question from Ryan Shane. He wants to know, are the plants subjected to grazing or herbivory at the site?
None.
So all animals were excluded from the...
Not necessarily, but the Columbia National Wildlife Refuge is, I suppose there could be errant cattle in the area, but I have never seen any cattle in the area, so I'm not aware of it. It's not promoted at the Fish and Wildlife Service to my best of my knowledge.
Okay. Next question is from Ryan Shane. Suggest adding subplots where bunchgrasses are clipped to 4 inches height above ground or burned. And okay, sorry, this is not a question, it's a comment. But suggest adding subplots where bunchgrasses are clipped to 4 inches height above ground or burned and monitored in subsequent years for restoration of plant vigor. Does that make sense?
Oh, yes, it does. The use of grazing to have an effect on bunchgrasses is well recognized by the farmers in the group I talked with a few days earlier. A lot of the conservation reserve plantings are managed without grazing, and a lot of the elder farmers are saying these plants are not doing well, that they need some form of stress to reinvigorate them or change their condition. So that's a possibility for my plants, is they were not clipped or raised or abused in any way.
Okay. Julie Conley wants to know, were the study sites subjected to any forms of disturbance, wild ungulates or other grazers?
No, not to my knowledge. The area had been grazed historically, but once the Fish and Wildlife Service took over the property, there was no further grazing to the best of my knowledge. And that's
any other sort of disturbances that might impact that area?
There has been fires. Beyond that, I don't see any other disturbance. Just cheatgrass, if that's a disturbance. It is in a way. It's just a change in condition, of course. But there's been no unusually dry years or unusually wet years. No pathogen issues that I'm aware of. I know cheatgrass can be hit by pathogens, and but I did not note that here. The effect on the bunchgrasses in my particular study area is open to question. I don't have a good answer for it.
Okay. And Julie also wants to know if this work is it published? Is there some way that that's available where people could find it?
Yes, the Fire Rich study was published, and that is I don't have the reference in front of me right now, but you can find the early study on the webpage at Washington State University. If you Google Shrub-Steppe ecology and Washington State University Tri-Cities, you should see the page. I'm also going to load this study on the website for the U.S. Fish and Wildlife Service, and it should thus be available that way. It should also be available through the Joint Fire Science Program.
Okay. All right. A couple more questions just came in. Kent McAdoo wants to know, are there any observable impacts from lagomorphs? Not sure if I pronounced that right.
What are those?
Lagomorphs, Lagomorphs.
Okay, define lagomorph.
Right, Kent, you might have to write back in and explain what that is.
Yeah.
All right.
I'm afraid I don't.
Oh, jackrabbits.
Oh, jackrabbits. Oh, yeah, excuse me. No, they're really, I don't recall seeing lots of jackrabbits either. I know their populations can go up and down, but I haven't noted lots of jackrabbits in Columbia Basin in a long time. Lately, there's been a few more, but they're not really a preponderance. Another potential problem is grasshoppers. I've seen grasshopper populations have been very significant in the past few years, but I haven't been to these study plots for 2 years, so I don't know if it has an effect.
Okay. Well, I just learned a new term, the legomorphs or lagomorphs. I'm gonna have to use that.
I'm a plant person.
All right. Ryan Shane wants to know, is there a relationship between cheatgrass and cryptograms that you observed?
Yes, if there's more cheatgrass, there's less cryptogams. Now, will cryptogams reduce cheatgrass germination? That's a good question. I think it could be proposed as the case. It's a testable hypothesis, I think. But I don't know. Anytime the soil is disturbed, it makes things more conducive to cheatgrass germination if the seed is available. But I would say the relationship between cryptogam cover and cheatgrass germination is something to be examined. I think it's been looked at before, but I don't remember exactly.
Okay. All right. So as that's all the questions that have come in, Stephen, I want to say thanks, and we appreciate you coming for the webinar. It's really interesting. This is a very important topic for a lot of people out in the West, and
yes.
Look forward to seeing more of this as the publications start to come out and more of this is made available.
Okay, thank you.
All right, well, thanks, Stephen. And for everyone else out there, also the recording of this will be up as soon as it's done spinning its wheels here on the computer. I'll upload it, and you can find the link to that on the Advances in Fire practice page and pass it on. All right, and we thank everybody for coming.